हेलो सर, आवाज आ रही है क्या?
हाँ, आवाज आ
हाँ।
रही है।
हाँ सर, ठीक है, थैंक यू सर।
If you had that, like RBF, we had one small we prepared. No, RBF. Okay. Hello? Hello? Hello?
Yeah, yes, sir.
Hello, very good morning to all participants.
Good morning, sir.
Today we are starting by 10:30 and there are three talks and all three talks are well experienced people at different places in their own place. And the first talk starts with Dr. Pradeep Kumar Nayak sir, who is the director of Rajiv Gandhi Institute for Groundwater Research under Central Groundwater Board and a well-known scientist. And actually the work which we started, his work was inspiration for us. So I requested him, would like to introduce him to all the participants, but he made my job easy that he told he himself will introduce. Sir, good morning, sir. Pradeep, sir.
Good morning, Dr. Purandar. Good morning.
Good morning.
Thank you.
Can you hear me, sir?
Yes, yes,
Pradeep,
very
sir?
much I can hear you. Yes, yes, I can hear you.
Hello.
Yeah, I can hear you.
Yes, yes.
Can you hear me, sir? So,
Yes, yes, I can hear you.
is it audible?
Yes, yes.
Hello.
Yeah, yes, audible, audible.
We are not. He muted it.
I think it's speaking.
No, I think I'm unmuted.
Yes,
Hello, hello,
Pradeep, sir's.
hello, hello.
Sir, you are audible, sir.
Yes, am I audible?
Yes, sir, audible.
Okay, great. Thank you. Thank you. Yes.
Hello.
Yes, 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 Dr. Purandar.
Hello.
We can hear you actually.
They can hear, but sir is not clear.
It is not speaking, but we can hear you.
You can hear. So, sir Pradeep Kumar, sir, I request you to introduce yourself. Actually, it would have I would like to give introduction to the participants, which will be very beneficial to them also. Hello.
Thank you. Thank you, Dr. Purandar. Thank you so much. Thank you so much. Hello.
This one is.
There is some problem probably. Tibian, am I audible?
Hello.
Yes. Yes,
Yeah,
yes.
now
Dr.
it is
Purandar.
audible. Yes, sir. Sir, good morning.
Okay.
Very nice to see you over. Very nice.
Good morning. Good morning. Good morning.
Nice. Good morning, sir.
Yeah. Good morning. Well, let me simply start actually.
Yes,
Well,
sir.
yeah. Can you hear? Can you see my presentation? Can you see it, Dr. Purandar?
No, sir. No, sir. That sharing may problem in the sharing, please.
Okay, I'll share it again. I will share it again. Share. Okay.
Now it is okay.
Yeah. It's fine, sir. It starts.
Okay. Okay. Can you see my presentation now?
Yeah. It's we can see it, sir. We can see.
There is something coming here.
Full screen. You can make it full screen also.
Yeah. I'll maintain. Something is coming. Entry point not found. I don't know what it is. Okay. Okay.
Yeah.
I'm getting a message that the procured entry point about could not be located in the dynamic link library. Something is coming.
Getting some problem.
Problem. We will check it, sir.
Okay.
It's operated from Roorkee. I am checking.
Okay, sure, no problem. Yes. Okay, let's start now. Yes. Actually, at the beginning, good morning to everybody, and I must thank NIH to have given me this opportunity to present springs of the Western Ghats. Actually, they are a vital source of water for the people living in the west, in the hilly tracts. I am Pradeep Naik from Rajiv Gandhi National Groundwater Training Research Institute, based at Raipur in Chhattisgarh state. I'll do a little marketing about my institute. It's the only institute of this type imparting training on groundwater in whole of Asia. And we have shifted to a new campus, and we have over 100 seated hostel available. Earlier we didn't have hostel, now we have hostel facilities also. So if you're interested, we actually impart about 40 to 60 trainings annually at Raipur. So if you're interested on any topic of groundwater, we deal with the vast gamut of groundwater actually, you're invited. Well, Dr. Purandar gave me this topic, occurrence and sustainability of springs in parts of Western Ghats, Maharashtra state. Well, springs are the lives of people living there. They actually they cater to the needs of drinking, irrigation, bathing, everything. This is their life, we can say. Also, the recharge to the aquifers present below them. They sustain the riparian zones. They act as if they are small stream flowing in the hilltops. If you go to Mahabaleshwar, you'll find this cow from whose mouth water is oozing out. And once you drink it, a glass of water, spring water, you'll be free of your diseases. It is said, it's claimed there. So this is from Mahabaleshwar temple, the hilltop, which receives about 6,000 millimeters of rainfall at the elevation above about 1,500 meters above mean sea level. They act as base flow also. In the hilly tracts, you don't expect base flow, especially in the hilltops, but they are there. They act as if they are small streams flowing. Something is wrong with this thing here. Okay. Okay. Yeah. But recently, in the name of development, there is thoughtless diversion of springs, which is giving a lot of economical damage, also public outcry. See, nobody is the owner of springs in the hilly tracts. They exist in the government land. So anybody who likes to, he can divert this movement of spring. There are so many cases like this, especially amongst the farmers, and it creates a lot of public outcry because people living downstream, they rely on the water, and somebody diverts the water. It becomes a great, big problem for them. In the name of development, also there is modification of the spring natural settings. It leads to diminution of springs discharges, shortening of their lives, and often their complete disappearance. Especially in this, a lot of springs are seasonal. And because of these problems, because a lot of development taking place, a lot of human interference, people living in the hilly tracts, they tend to come to the downstream. They have to come down towards the valley side, they have to take water in their pitcher like this. They even wash the clothes and carry the water to the hilltop again. So they face a lot of hardships because of mismanagement of spring water, mismanagement of the springs in the name of development. We are dealing with the Western Ghats, and we are now in the Maharashtra state, northern part of the Western Ghats. Little bit I'll speak about it. 1,600 kilometers long, 1,000 to 1,300 meter above mean sea level, rainfall about 4,000 to 6,000 millimeter per year. The area in which I worked has about this much of rainfall. Flat hills with extensive terraces, narrow winding valleys. These hydrological features, they play a great role in the origin of springs in the Western Ghats. Western Ghats, they have poor surface slope conditions, greater surface runoff, low rate of infiltration, which leads to limited groundwater recharge. So people living in the hilly tracts, they solely dependent on spring. I'll highlight a little bit about the area. There are a lot of irrigation projects coming up in the area because of the congenial situation. There is a big boost to agricultural productivity. Sugarcane is the most favorite crop in this tract, especially in the valley areas. The Krishna River is famous for that. Surat is the area of Surat power. You may be knowing what Surat power is. But there is growing economic disparity between the common and non-common areas. The common areas getting a lot of waterlogging problems, which is leading to soil salinity. And people living in the non-common areas, they simply seem to the fence and see the development. People in the hilly tracts, they belong to the non-common area. They see the development taking place in the valley parts, which draw attention of everybody, and they feel neglected. Once you visit the area, you will see the way they talk. Yes, they feel as if they have been neglected by the government. They don't have attention of the government, you can say. So what the Western Ghats needs is the better water resources management and development. Development of the springs. I studied this Koyna area, which is famous for the Koyna earthquake in 1967. I studied about 2,000 square kilometer area. You can see the bold line in between the divides, the water divide, the northern part, southern part. Northern part is the Koyna River basin. And southern part is the Patan, Malarpet, this Ghat is in the extreme right, but the Krishna, the Koyna meets the river Krishna. So this southern part is bit thinner, not as plain as you see, but it is a relatively plain area compared to the northern parts. These are physiographic features. You can see the hatched portions in the top areas, in the top areas. They are the plateau areas, and they are mostly laterites. These are the geologic features. Alluvial, we have the Ghat area in the eastern part. We have a little bit of alluvium, about 5 to 10 meter thickness. Laterites mostly in the hilly tracts. The laterites play a great role in the origin of springs. They were earlier actually basalts, but they have been lateritized later on. Lineaments, they are the alignments of the lineaments, northeast, southwest direction mostly. So, if you have studied basalt, you will see that typically it consists of 3 units. Massive basalt below, that consists of about 60% of massive part of the basaltic flow. Then we have vesicular basalt, about 40%. Then we have red ball. Red ball is not a flow actually. That becomes red because of the another flow comes up above it. So you can very well see here. The 2 flows. Below the red part, we have 1 flow. Above the red part, there is another flow. See red ball. Red ball is clay mostly. They also play a great role in the origin of springs. I'm not going to the how they have been originated, but I'll just say that there's the massive basalt, with massive in character. Sometimes they get weathered and fractured. We leads to again to the springs later on. They are the fractures in the basalts. They play a great role in the origin of springs. There are different horizontal fractures in basalts. Weathering also is taking place. You can very well see. This is the vesicular basalt. There are vesicles in it. So above each massive basalt, characteristically, you'll find massive basalt about 3 to 5 meters. Above this, again, you'll find red ball. So the laterite in the hilly tracts, the top, actually they are massive basalts. They are lateritized and they have formed thick, about 10 to 20 meters of laterite cover in most parts of the Western Ghats around Mahabaleshwar area. The talus deposits have been created due to weathering of these laterites in the hilltops. And we have a lot of hill terraces. That is the characteristic of the Deccan Trap terrace-like features. So I'll just give an overview, like just to have an imagination as to how the basaltic flow is. Please have a look at it. There are two flows here, flow 1, flow 2. Flow 1 is older than flow 2. Flow 1, we have 3 units, again 3 units, but in hard massive basalt, we have jointed massive basalt and weathered vesicular basalt, the red ball. And flow 2, that is near the surface, exposed to the surface, has more units, litho units. Hard massive basalt, poorly weathered and poorly jointed basalt, poorly weathered and highly jointed basalts. This region gives the most of water in the dog wells. Then we have highly weathered and highly jointed basalt. Then you have to reduce clay, the red ball, when they were black cotton soil. I'm telling you this because these features play a great role in the origin of springs in the hilly tracts. These divisions are not different that you have to find in the high elevation areas also. They are the same. Okay, that's why. So yeah. So what is happening? The Western Ghats area has a lot of water problems. The water scarcity in the deserted plateau of the Western Ghats is a direct function of lack of saturation of the aquifers, owing to the rocks being well drained with the slope conditions. And abundance in the central valley is because of the situation in this direct discharge area of the basin, and also in the region of maximum irrigation, both of which cause high water levels. So the hilly terracetic plateau, harnessing of springs is one of the solutions. In Koyna River Basin, the Koyna Dam is here in the central part. I studied about 120 springs. There are innumerable springs. I want to count the how many springs occur in an area. I studied about 80 square kilometer per area, one quadrant of a toposheet. And if you see the toposheet, they look all plus actually. So I visited them personally. I found that there is one spring in every square kilometer per area. Of course, if you see the recharge area, I'll be showing you of the springs. They are about 722 square kilometer. You'll find about 722 springs. So that gives rise to one spring in every square kilometer. So there are innumerable springs. Of course, this work has been carried out. So early 90s, I hope the springs will still be there. There is one young hydrogeologist. The name is Rennie Thomas. He's working in Western Ghats. He just called me some few months back. He wanted to locate these springs where they are. In those days, we didn't have GPS to know the location, exact location of these springs. But I sent them list of the villages and the direction where they are available. I hope he did some work. He might have done some work. I'm not in contact with him. So I hope he has done some work. So in the Western Ghats, you'll find two types of hills. One is of narrow ridge. Another is of flat-topped hills. The figure that figure you saw earlier was of flat-topped hills of laterites. Both these types of hills, they give rise to springs. You can find stellar deposits as the weathering feature of the hilltops. So the right side hill, that is the flat-topped hills, they have the most of the springs in the area. This is the typical top of hill terrace, top of the Western Ghats. There is a place called Swadavagapur. If you go near Y, west of Y, is Swadavagapur. So the plateau area, the hilltop about 1,000 meters above mean sea level. This is my wife, my beautiful wife, looking at the hill terrace in the Mahabaleshwar area. I went there for honeymoon. So you can see the villages are sitting in the hill terraces. You can have several football fields in these hill terraces. So the springs cultivate about more than 100 acres of land. They are the hilltop, not the plain areas, about 1,000 meters above mean sea level. They look like as if we are in the plain area, but we are not. And these green patches that you see, mostly of wheat and rice, they are done by spring water. So this is a model of the origin of springs. Let us go to the left side of the figure. We have a flat-topped hill. Rainfall takes place, and we have laterites, highly weathered. Rainfall easily infiltrates into it. Then below laterite, we have lithomargic clay. Lithomargic clay, the characteristic of the area. Actually, I didn't know earlier what is lithomarg the time I studied there. There is a science college at Karad, a YC science college. I happened to meet Professor Dikshit and Professor Umarjikar there. And this happened to be the field PhD area of Umarjikar, sir. So he explained me what lithomarg is. This is one of the very important features in the hilltop. So wherever you find lithomarg below laterites, definitely you will have springs. So a lot of springs ooze out at the contact between the laterite and lithomargic clay. Also, we have talus deposit. The talus deposit, they absorb, they are highly weathered, they are highly unconsolidated, and they have a lot of water in them. And whenever they are in toss, whenever they contact between the hill terrace and the talus deposit, you will have these springs. So any kind of disturbance, rainfall, when they infiltrates down the hill, just in the basalt itself, laterite itself, a simple, any kind of obstruction leads it to horizontal direction, or the flow becomes horizontal rather than vertical. You can see the right figure. The vertical arrow marks are the infiltration of rainwater, and the horizontal direction, the arrow marks are a flow of water. They get diverted due to slight obstruction of its path by the different basaltic units. I am up to 1, 2, 3, 4, 5. 1 is laterite, 2 is polylaterized basaltic flow. They are getting in the process of lateralization, have not been laterized yet. 3 is vesicular basalt. I hope there is 3, yes, small part is 3. 4 is weathered massive basalt. 5 is moderately weathered or hard massive basalt. So even the hill terrace, if they are still basalt, they have not been laterized, if it is exposed by the like the vesicular basalt is exposed, or even the weathered messy basalt is exposed, rainwater still infiltrates down, and as it goes down, it gets obstructed by the moderately weathered and hard messy basalt or hard messy basalt. Then they come out on the hill face at spring. So this is just a lithological model of the springs. So we have the springs occur generally between the litholaterite and lithomargic clay or polylaterized basaltic flow. About 9% of springs I studied out of the 120 springs that I studied personally. The vesicular basalt and non-vesicular messy basalt, 20%. Highly weathered messy basalt and moderately or poorly weathered messy basalt, about 20%. Or a like this feature is very important. Highly weathered messy basalt and moderately or poorly weathered messy basalt. They are like universally they are found in the whole of most of Deccan troughs. So this third origin is very important from Western Ghats perspective. Then we have talus deposits and hard messy basalt or laterized basaltic flow. 23% of springs they come out from this origin. We have also fractures. I showed you some figures of pictures of fractures. Also, they come out from the fractures. They are not vertical fractures, but the most horizontal fractures. We have few vertical fractures also, but they are not very deep. Otherwise, if they are too deep, then they give hot spring. You have to find the western part of the Western Ghats. I want to tell you one thing that I went even to the western parts of Western Ghats, like Chiplun area, if you know the area, Chiplun area, the Bombay, the Goa highway is there in the western parts of Western Ghats. We don't find as many springs as we find in the eastern part of the Western Ghats. It is because the Deccan basaltic flows are a bit tilted toward the eastern side rather than to the western side. That's why the water has a tendency to flow toward the eastern side, toward the Karad, Wai, Pune side, not towards the Chiplus, not toward the western part of the Western Ghats, but toward the eastern part of the Western Ghats. So mostly that's why you'll find most of the springs are generally existing in the eastern part of the Western Ghats. So the just a number classification of springs like laterite springs. We have about 7 springs I studied. They are lateritic origin of 9% of springs. Talus spring. This classification is based on the source aquifer. Source aquifer for laterite springs is like laterite. Talus spring is talus. Talus is not an aquifer, but still it gives rise to the origin of spring. Springs coming out from talus will be a talus deposits. And if the source aquifer is vesicular basalt, like they are found at the contact between vesicular basalt and messy basalt below, it's called PP springs or vesicular basalt spring. If in the messy basalt itself we have 2 units, like a highly weathered messy basalt and moderately or poorly weathered messy basalt, then we have a lot of springs, 28%, about 37% of springs, they come out from this. Most of springs come out from this origin, messy basalt spring, MP springs. Then we have fracture springs, about 11%. Then we have this is a picture of this laterite spring. The laterite, the red part is laterite, the lithomargic clay, the Sadabagapur, if you know this area, Sadabagapur, near Mahabaleshwar, near west of Y. So this is the lithomargic clay. This is a talus spring. Above it is talus deposits. They are coming out of the talus deposit, between the talus deposit and the moderately weathered messy basalt below. We have this is a messy basalt spring. We have weathered messy basalt above, hard messy basalt below. The messy basalt spring. And we have again something, this vesicular basalt spring. The gray part you see below the boulder is vesicular basalt. About 1.5 meter of vesicular basalt is there. Of course, this part is a bit weathered. It becomes difficult for me to take photograph inside. So there is a massive vesicular basalt spring that coming out between at the contact between vesicular basalt and the massive basalt below. Then we find it's just spring, just like spring line below the Siwaliks. We have many such spring lines below a basaltic flow, just at the contact between the hill terrace and the hill slope. There are spring lines. There are springs come out from this at one level. At one level, it find a lot of springs coming out from it. Then I just wanted to see what is the source of recharge, or what is the area from which this spring get recharged. So I mapped it actually. So the horizontal lines that you see at the hilltops, they are the recharge area of the springs. Most of them are laterites or weather massive basalt in the hilltops, the hill terraces and all. So they are the spring areas, about 720 square kilometer out of 2,000 square kilometer that I studied. About 35% of the area, they are spring recharge areas. Then we have this is the elevation-wise distribution of the springs. About 600 to 700 meter above mean sea level, we have about 11% of spring existing. 700 to 800, about 10% of the springs. Most of the springs are between 900 to 1,000 meter above mean sea level. Between 1080 to 1060 to 1080 meter above mean sea level, we have a extensive like lateritic flow, the lateritic bed. So that gives rise to a lot of springs between 1,000 to 1,100 meter above mean sea level, about 13% of springs. Most of these springs are laterite springs, like this. So as you go up about 1,000 meter above mean sea level, we don't find as many springs because those water are still infiltrating. They are still coming down and they are feeding the aquifers below. So that's most of the springs they actually are existing up to 1,100 meter above mean sea level and not above them. Very less springs you'll find if you go once you rise, if you climb the hills. Then this is how the spring discharges are measured. And we have a 10-liter bucket, and I just stopwatch with me. So I was just seeing how much time it takes for the 10-liter bucket to fill in. I was starting the stopwatch and stopping it. So that way I could measure the spring discharges. So this is the measure of spring discharge. Winter time, the mean discharge come out to be about 46 meter cube per day. And if you calculate annually, about 8 MCM of water, spring water comes out from these springs in the western winter season, about 2 to about 432 meter cube per day. See, there are very large springs. They come out as about 20 horsepower water in the hilltops. They make a lot of noise. They are of 432 meter cube per day, as good as a river. They come out as base flow. These springs must be tapped for the people living in the Western Ghats, in the hilly tracts. I remember the May also I visited, I took samples of some discharge samples of some springs. Most of these discharges are otherwise reported. It's about 1 meter cube per day to about 260 meter cube per day. So many springs they get dry in the summer time, but many of them are perennial. These as per the Manger's classification. Manger is a great worker of the spring. He has made a very good classification in 1923. So the spring discharges have been categorized based on the Manger's classification, 2 to 12, 12 to 14, 24 to 36, like this. So mostly 6th order spring you'll find in Manger scale in Western Ghats. The order of springs like first order, second order, third order, fourth order of springs, they are as per the discharges. So if you get less, then it will become, you'll get seventh order of spring. It is not like the main scale is not like the classification that we do of the spring, first order, second order, like that. But it is just opposite. As you go higher, you get less discharges. So fifth order spring are high discharge, seventh order spring are less discharge. So the springs of Western Ghats, they vary between fifth order to seventh order spring. Mostly they are 90% or 80%, they are mostly sixth order spring in Manger scale. Then you see the chemical quality. I have 10 minutes left still. So the three types of spring: basalt, laterite, talus. The three types of aquifers, they are found in the Western Ghats. So they are the aquifer-wise chemical quality of the springs coming out there. So if you compare the well water, the borewell water, river water, the spring water, this is a comparison. Borewell water in the area, they are more mineralized. They are more mineralized than even the dug well water, because they come in contact with several flows below the ground, and they are more mineralized. That's why. The spring water, the TDS is typically 90, from average TDS 90, is very 50 to over 300 TDS. There is highly, you can very well drink it. But one problem is that it has got high amount of iron in most of the places. You find the iron here, Fe, below. It is less than 0.5, 0.7, 0.45. And 0.3 is the criteria by the GIS. So some springs, they give high amount of iron because of their lateritic origin. Most of the springs which are lateritic origin, they have higher amount of iron. But this is not a problem in the area. People have been drinking this water for a long time. And there is no globomothamia, that disease you find due to high amount of iron. So it's just like iron capsule you can take in those areas. So a lot of springs have been converted as dug wells in the hilltops. They are the hilltops about 1,000 meters above mean sea level. This is place called Kolewadi, just west of Wai. So this is hilltop, and things have been harnessed, like by the government of Maharashtra, GSDA. They've been doing good work in this area. So, and the water supply departments, they bring the spring water through pipelines. They store at one place. The man standing there in the top of the storehouse. Then they are supplied through pipelines to the villages through gravity. So there are not much expenses. They have to pay the price only for the pipelines and the storage tank construction. There no need to optionalize through motor and etc. They can very well operate through gravity. So the Mahabaleshwar area, this is there since the British Empire, since long. This is the tank which supplies water to the whole of Mahabaleshwar city. Of course, in Mahabaleshwar area, a lot of hotels, they have reserved a spring themselves. So as I said, nobody is the owner of the spring. If somebody likes to, he can very well go and tap and own a spring and use it for its own purpose. I have been campaigning for this, that government must, own this spring, or they must do something so that this does not become a man's property. At least government owns it. So a lot of farmers, they store the water and they irrigate their lands in the hilly tracts. They irrigate wheats, etc., vegetables, etc. This is my typical bucket I used for my discharge measurement. This is how the farmer here is helped. They helped us in the field study that he is doing wheat irrigation in the hilly tracts near Mahabaleshwar area. This is how the rich hotels, they tap the spring. This spring water is going to a big hotel in Mahabaleshwar. So what are the lot of springs? They actually, their regions, they are not doing well. A lot of schemes have failed in the hilly tracks. People depend. That's why they don't have confidence in the government sometimes. We tap only one spring for a larger population, a larger, like for a population, for the village of large population. Then we don't thoroughly the spring flow domain. We don't measure it. We don't measure the winter flow, the summer flow, etc. Because it is there. We go to winter time because it is there just connected to the village. In the summer, they have problems. There is breaking apart of pipelines because a lot of wildlife they move around the area. So they rub their bodies with the pipelines and the pipes they get when they are exposed to the surface, they break apart. And you know how difficult it is, the hilly trucks at the top of the hill to maintain them, to again put them in alignment is really difficult. Silting off of the small tanks at the spring origin, because every tank, generally they have the small tank from actually a storage tank kind of thing, and that tank supplies water where they get silted off. Leakage of storage from distribution tanks, the storage tank that you saw, there are leakages unless they are maintained properly. But with leakages and water seep out from those tanks, and they give rise to water loss. Then a lot of mismanagement of the stored spring water. I'll just show you some of the pictures. The broken pipelines. The man who is actually fasting this morning, he just came with me along the hills, just show me how broken the pipes are. Actually, when I was climbing the hill, I was just climbing, then walking about 5-10 kilometers in the hilltops, exploring the springs. Actually, it is really a good experience once you go there. Actually, it is silting up of the broken pipes again, silting up the area also, like silting up. Yeah, this is a silting case. This is a spring origin in the just below the big boulders, and they got silted off. The two compartments already have been made, and still they are getting silted off. So they need maintenance. They need maintenance because spring water sometimes they bring some sediment also with them when they flow along the path, and those actually silt off. They silt off the catchment, the portion that catches them actually. Then we have the broken pipes again. Of course, they are the broken tanks. They are these waters they flow continuously, and they could at least be used for horticulture purposes. There is a pipeline. There is a open channel transporting water for long distances. At least they could be the pipes could be used instead of these, so that we can save the seepages. There are seepages into the open channels. So forestation is a big problem in the Western Ghats. They are mostly barren. So these spring waters could be used even for forestation purposes by tapping the right kind of spring, by the springs flowing continuously. Government can take advantage of these continuously flowing water and can use them for forestation purposes. And so if somebody likes to do some spring study, what are the steps? What steps one should follow? So they are simply the steps around. Write down. Actually, I just put it down based on the experience that I had in Western Ghats. Examine seasonal discharges thoroughly. Don't tap a spring unless you are confident of the discharges it gives. Measure even the summer discharges so that people will not suffer in the summer time. Tap 2 or more springs if need be. Monitor water supply schemes periodically. This is very essential. This is very, because once you implement it, you must monitor also. Then store surplus water for irrigation purposes or horticulture purposes. Construct rainwater harvesting structures. This is a thing actually in Sadabagapur, they have tried. When they visited the area, there is a professor from Pune University, Professor Ghare. I don't know if he's there, still there. So he used to run an NGO. So I just happened to be there with him. So they occasionally they hold meetings also, and they do shramdan. So the people in the area, they do shramdan and they dig some kind of tank in the hill on the hilltops. And those tanks actually give rise to the spring flow. The flow of the springs, the springs do not die because of these tanks. So more such tanks could be made on the hilltops, and they should be connected. They should be punctured so as to the even Nasibatu to the actually the aquifer, that is the origin of the springs, so that the springs will not die. They will still be there even in the summer. So those actually, there I could see only one place, Sada Bhagapur, only one tank where this is there and it is working well. So similarly, many tanks could be made in the hilltops instead of focusing only on the valley side and constructing percolation tanks, etc. You can focus also the hilltops. So those tanks can very well serve the purpose of discharging to the springs below. And pipelines conveying water from springs, construct barbed wire fence around springs, spring head protection. You must practice in these areas to save the springs from their extinction. So to survey a spring, you must do the following things: location of springs, geological set of geographic conditions, type of springs, source aquifer, very important, spring classification, seasonal discharges, monsoon, winter, summer, spring recharge conditions, including the area of recharge. Then we have water sampling for chemical quality, scope of development, environmental concerns, if any, probably yield after development, possible usage after development, capacity of the springs in meeting desired water requirements, and other remarks, if any. So I conclude like this. Spring origins depend on the physiography and lithological characters of source aquifers. Spring discharges vary with lithology and hydraulic characteristics of source aquifers. They are very important. The source aquifer must be recognized well. Spring flow domain has marked seasonality depending on recharge. Spring hydrochemistry depends on residence time of groundwater issuing at springs. Chemical constituents are well below the GIS and WHO standards, except for iron at three locations. Then we have springs are an important source of water and must be harnessed effectively. Reforestation could be a new use, even they are not started yet. A trade-off must be made considering local needs and downstream uses, because springs have their own riparian zones. A lot of organisms, plants depend on these springs. Emphasizing only on local human needs might lead to severe inter-community conflict and negative environmental consequences. Well, many papers I have published, made 3 papers in journals and few reports actually. So if you're interested, you can go to my ResearchGate site and you can download them, or if you email me, I have my email ID, I can very well mail you these things. That's it, Dr. Purandar. I finished. Always ask questions. Yes.
Yeah. Thank you, Dr. Pradeep Kumar, sir.
Yeah.
It is an excellent talk and a well-experienced talk. So I request because you are online available. I request the participants, if there is any questions, we can take 2-3 questions if they have any. Like.
Good morning, sir.
Hi, good morning.
I am Professor Nagesh from Reva College.
Yeah, please.
I just happened to go through your lecture, and I have a little bit clarification regarding Kannat. A channel like say a tunnel like thing which intercepts the water table with a gentle slope and feeds for irrigation and drinking farmers for drinking purpose. Probably in say Gulf countries and all. Most of them they are in Gulf countries. And coming to the springs, they also tap the water in the aquifer below ground level and from water table as such. Okay. Can you comment on the springs in comparison with Kannat? Because as I see in the slides and all, they are tapping the groundwater from underground by inserting pipes, something like that, so that the water is fed for their purpose. Any comparative statements that you can make with Kannat and springs, sir?
No, Connect actually, they are the old features. I don't think we have Connect actually here in India. So I don't know if they are, I don't think they are spring actually. They are the man-made feature. They are not natural spring. So I don't think they could be classified as spring. You can say, human-made spring, you can say. So what Western Ghats springs are most of the natural springs. The springs existing in the nature. So it is not, if once you disturb the springs, you may lose the spring. So the only difference that we find is they are the connects are the man-made features. The
Yes,
springs are the natural.
okay. I have to understand that connect are say man-made features and springs are natural and tappings are done for utilization, right, sir?
Yes, 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 yes,
Okay,
yes.
sir. Right, sir. Thank you, sir.
Any more questions? Any more? Hello?
Yeah, please. Okay.
No more? No more questions, please. Hello? Any questions? Any questions? Sir is available now. If you want to clarify, you can clarify, please.
Okay, me, I want to ask about spring discharge method.
Yeah, right. Yes.
So he
Correct.
use a bucket and the discharge not clear. So he can clarify more about that.
Uh,
Yeah, I'm knowing
well,
one
actually,
from Uganda.
well, there are a lot of background noise coming. Actually, there are a lot of background noise coming. So, so actually, yeah, spring discharges could be measured by two ways. One is if you're having a sort of bucket kind of thing. I think, can you, Dr. Puranda, can you mute everybody? Can you mute everybody? There are a
Yeah,
lot of
yeah,
background
yeah,
noise coming actually.
yeah. Yeah.
Yeah. Yeah. There is a dog actually shouting probably. Yeah. So this spring discharges could be measured in two ways, either a venous method or by the volumetric method. So in the hilly trucks, venous method like it is difficult as we do in the while doing exploration in the boreholes. If you are drilling a borehole, you can very well channelize the water coming out of the borehole in a sheet as a sheet of flow. And such features are generally not existing in the hilly tracks. So it's better to take help of a pipe actually and allow it to flow in a bucket, a measured bucket, and you have a stopwatch and see how much time it is taking for the bucket to fill. So that way you can see per second discharge of spring. So that is the best way in the hilly tracks because the physiography will not be congenial. So the best thing is to connect the spring origin with a pipe, then measure the flow of water in a measured bucket. So that's the best thing I can find in the spring discharge measurement. Are you happy with this?
Yeah. Any more? Any more?
Sir,
Hello?
sir,
Yes,
hello.
yes, please. Yes, yes, please.
Myself, TVN Singh, sir.
Yeah, TVN, what? Yes, yes.
Please. Sir, I just wanted to know sometimes classification of a stream is very difficult. Is it
Yes, yes,
compacted
yes.
spring or fractured spring? How to classify the springs? So,
Well,
that
actually, a lot of work has been carried out on the classification of springs. Lot of work. So in the Western Ghats, mostly we have a contact springs. They are found in the contact between two aquifers. So they're mostly contact springs. So the springs coming out from the fractures, they are the fracture springs. Otherwise, most of them are contact springs. There are other different, there are the various kinds of classification, even chemically also. So it depends on the type of spring actually in the area where you're working. You can classify the springs. Yeah.
okay,
So
sir.
they're not defined rule actually. So it depends on the area and the type of spring that is coming out.
Okay.
Hello.
Yeah. Yes, yes,
Sir.
yes.
Myself, Dr. Vijay Parkhode from GSD Pune, sir.
Yes, yes, yes.
Sir, your presentation is excellent, sir. Sir, I just want to know have you studied how to identify the spring shed area? Means area which is recharging the spring actually. So is there any methodology particularly to protect that area or control that area?
That is a good thing. That is excellent work actually, and a lot of people are working on that. The preservation of spring set. This could be done in the Western Ghats. This is yet to start because ownership of the area is difficult. Like ownership of the springs, and it is very well. You can very well demarcate a spring set. They can very well demarcate it and well protect it. Yes, it depends on actually, but it is a good idea. It must be done. It should be done actually by this time. You must protect all these springs by identifying their spring area. Yes, it's a good idea.
Thank you.
Actually, I will tell you the springs are just like rivers. Not much difference between rivers and the spring in the hilly tracts. Yeah. Okay.
Okay, I think questions are over. Sir, thank you. I would like to express my deep hearted thanks to you for delivering such an excellent talk and your experience you shared with all participants. And we will be highly thankful to you, sir. And I hope in future we will be able to take your guidance also in doing some work. Our center, though may not be personally, but at least our juniors will take those things further forward. Yeah, okay. So now the second, thank you, sir. On behalf of both NIH and as a person, I thank you, sir. Thank you. Thank you. So the next speaker is ours, Dr. Lingaraju. National, that is, he's a now river rejuvenation projects director, also acting with the Art of Living, associated with the Art of Living, Ravi Shankar ji. So my colleague, Mr. Abhilash, will introduce him, and I welcome Sri Lingaraju sir to the talk now. I hope he is available. Just.
Thank you, sir. I'll take over the things. Dr. Y. Lingaraju, his rejuvenation Art of Living. Dr. Lingaraju Yele is a well-known hydrogeologist who formerly was Director, Karnataka State Remote Sensing Application Center, Director, Geomatic Center, Water Resource WRDO and Government of Karnataka, R&D Lead in Global Academy of Technology. He has long and illustrious career in the field of hydrogeology spanning over 5 decades. He is a fellow of Geological Society of India and member of Indian Society of Remote Sensing and National Institute of Hydrology. His experience includes conducting geological and hydrogeological investigation, including remote sensing techniques and geophysical surveys used in water resources and natural resources planning and monitoring system. He has established many GIS and remote sensing labs. He was the engineering geologist at Varahi Hydroelectric Project. He has guided many research scholars and he is also a popular science writer. Other vital projects have been in the areas of groundwater exploration, watershed development, mineral exploration and mapping, and sustainable development of drought-prone districts of Karnataka and other regions. He is also involved in groundwater exploration of problematic towns and villages of Karnataka. Dr. Lingaraju has served as an expert member in initiatives in groundwater resources, drinking water management, flood mitigation methodologies, artificial recharge, dam safety, studies on impact of tunneling, irrigation, and application of geometric techniques for water resources planning and investigations. He is currently a National Director for River Rejuvenation Projects by Art of Living. He is responsible for planning and monitoring of river rejuvenation projects by Art of Living spanning over 4 states, currently Karnataka, Maharashtra, Orissa and Tamil Nadu. With the blessings of Gurudev Sri Ravi Shankar ji, under the able leadership of Dr. Lingaraju Yele, the river rejuvenation team has taken up projects to revive more than 40 streams, rivulets, springs and many rivers, for which Limca Book of World Records have recognized their efforts. Sir, the virtual room is all yours. please take over, sir. Sir, kindly unmute your mic, sir. Unmute your mic.
ಸರ್ ಅಂದ್ರೆ ಈಗ
Sir,
2017 ಸರ್ ಇದು ಅಗ್ರಿಕಲ್ಚರ್ಗೆಲ್ಲ ನಿಲ್ಲಿಸ್ಬಿಟ್ಟಿದ್ದಾರೆ ಸರ್ ಪಾಯಿಂಟ್ ಕೂಡ
Sir, please unmute your mic. Lingaraju, sir. There's a mute and unmute.
ಪರ್ಪಸ್ ಕೊಡಬೇಕು ಇನ್ನು ರೈತರಿಗೆ ಅಗ್ರಿಕಲ್ಚರ್ಗೆ ಏನು ಕೊಡಬಾರ್ದು ಅಂತ ಒಂದು ಆರ್ಡರ್ ಇದೆ ಸರ್ ಅದು ಪ್ರೈವೇಟ್ ಅವ್ರು ಮಾಡ್ತಾರೆ ಸರ್ ಪ್ರೈವೇಟ್ ಕಡೆ ಮಾಡಿಸ್ಕೊಡ್ವಿ
I think he is disconnected.
ಸರ್ ಮಂಡ್ಯದ ಕೃಷ್ಣೇಗೌಡರು ಅಂತ ಮಾಡ್ತಾರಂತೆ ಅವ್ರು ಜಿಯಾಲಜಿಸ್ಟ್ ಅಂದ್ರೆ ಅವ್ರ ನಂಬರ್ ಇಲ್ಲ ಸರ್ ನಮ್ಮ ಹತ್ರ ನೀವು ವಿಚಾರಿಸ್ಬೋದು ಹಾ ಸರ್ ಏನು ಪಾಯಿಂಟ್ ಮಾಡಬೇಕು ಅಂತ ಯಾರಿಗೆ ಪ್ರೈವೇಟ್ ಅಗ್ರಿಕಲ್ಚರ್ಗೆ ಇಲ್ಲಿ ಯಾವ ಅವ್ರ ಲೋಕಲ್ ಮಂಡ್ಯದವರೇ ಅಗ್ರಿಕಲ್ಚರ್ಗೆ ಪಾಯಿಂಟ್ ಕೊಡಂಗಿಲ್ಲ ನಾವು ಪ್ರೈವೇಟ್ ಮಾಡ್ಬೋದಲ್ವಾ ಪ್ರೈವೇಟೇ ಮಾಡ್ಬೋದು ಅದು ಅಫ್ರೆನ್ಸ್ ಅವ್ರನ್ನ ಪ್ರೈವೇಟೇ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಎಲ್ಲ ಇರ್ಬೇಕಲ್ಲ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಐತೆ ಮೊದಲು ಹೇಳಿ ನಾನು ಹೇಳೋಣ ಮೇಲೆ ಹೇಳಿ ಸರ್ ನೆಕ್ಸ್ಟ್ ಸತಿ ಏನಾದ್ರು ಫೋನ್ ಮಾಡಾಗ
Nandish, sir, can you please mute your mic?
Hello.
ಮೇಡಮ್ ಒಂದು ಮಾತು ಹೇಳ್ಬಿಟ್ಟು ಹಿಂಗೆ ಮಾಡ್ಕೊಡ್ರಿ
Hello, Abhilash, am I audible?
Yes, sir. Yes, sir. It's audible. I think Nandish, sir, is. I think that mic is. Their mic has to be unmuted. Muted.
ಮೇಡಮ್ ಒಂದ್ಸಲ ಕೇಳ್ತೀನಿ
Hello, Lingaraj, sir. Yes, sir. You are audible.
Yeah. Okay. Thank you, Abhilash, for having introduced me in a nice way. First of all, I would like to thank Purandar sir and Abhilash for inviting me to deliver this talk. I have been working in this area, as Abhilash said, since almost 5 decades, and my journey itself will explain how the water resources are getting depleted and what are the reasons and how to make the water availability sustainably. When I joined the department of groundwater, which was the first department to start in the country, there was scarcity of water, but not much was known about the groundwater. We were instrumental in exploring the groundwater and proved that a lot of groundwater potential is available during 1970, early 70s. But because we were very happy to make the people use groundwater, but
Sir, sorry to interrupt. Sir, just a second. Sir, can you please share the content, sir? Your screen is not visible, but the voice is audible.
No, I'm not sharing any screen. Just it is a talk.
Okay. Okay, sir. Okay. Fine, sir. Okay.
So shall I continue? Hello.
Yes, sir. Please continue, sir.
Dual camera. Yeah. Yeah, I was just telling about the groundwater situation, because the springs are very well connected to the groundwater, and the groundwater exploitation was so much increased in about 1 or 2 decades. Whatever the potential we could explore and make the people that generation happy, started finding the scarcity of even the groundwater and even the surface water, because there has been connection between the surface water and groundwater, and it is the geohydrological process which has been making the water flow through the entire river basin, and whatever the happiness we got by exploring the groundwater made the surface water bodies depleted, and the very climate change also is happening because of the over exploitation in a matter of 3 or 4 decades. So to bring back such a situation, which the climate was resilient and water scarcity was very rare, we had to work on this rejuvenating or regenerating the processes. So what is the framework? Some people work on the groundwater recharge, some people work on the water bodies, some people work on the springs like this. It is all scattered, and but in nature, all these are connected, well connected, and the influence of one source will have the negative effect on the other source also. For example, in the olden days, just 3-4 decades back, we had a lot of water bodies which were built across the natural streams, and the water was available through the year, and even these shallow open wells which were used by manual mode were always full of water. But later on, as the technology developed, the exploitation of the groundwater started, the one side, and the other side, what is the process which makes the water renewable? It was not properly understood, because it is human to focus on the attention of exploitation rather than thinking of the natural renewability that existed ever since the earth came into existence. So the overexploitation of groundwater and degradation of the water bodies. How the water bodies degraded? It is the drastic land use change which made the natural process of renewability of these sources got distorted. The hydrological cycle became defunct or disjointed. So the springs are very interesting sources. It's not. We should not call that as source. It is a resource because they are meant for nature, and they are all in the elevated area, hilly area. Now, because of the scarcity, we are thinking of exploiting that water also for human beings. But all these natural sources, resources, are meant for the entire ecosystem. That is where I would like to connect the river basin to the ecosystem, and I call that as riverine ecosystem. See, if water should be available in the entire river basin, and part of the path, the very starting point of a stream will have invariably some springs. These springs are the starting point of the journey of the water in the entire river basin. And rivers are not just a stream course which carries water, but it is a network of small streams which are carved out in nature due to the inherent geology and geomorphological processes that happened in the history of the earth. When we see all this in the entirety, we'll be able to appreciate how nature itself was managing the water resources in an integrated manner and provide the water to not only to the human beings, but for the entire life system. Whether it is for the microbes in the soil or the very aquatic animals, terrestrial animals, even the aerial things, because the riverine ecosystem provides this water in different direction and make it to reach every being. And human beings are also part of the entire ecosystem. So any distortion to the ecosystem is distortion to the human beings. That is where, when we want to bring back the original luxury of having water anytime, everywhere, we need to work on the entire riverine ecosystem. That is where I would like to link the springs and then its sustainability and its role to the entire riverine ecosystem or the river basins. Since almost 8 years, I have been working on this to rejuvenate the rivers. And my experience, previous experience of exploitation of groundwater, going for geophysical surveys, drilling, so many techniques. And when I started working with the ISRO for a mission called Integrated Mission for Sustainable Development, where we could see the terrain in a synoptic manner and repeatedly, we could appreciate what is happening where and how these natural resources are interlinked and how the distortion, if there is a wasteland, how does it become waste? No land is waste, but because of the erosion, siltation, everything, this man-made, more of the anthropogenic reasons, it could be mining or it is a change in the land use, drastic change in the land use is resulting in the scarcity. And the natural management that existed is getting distorted. So, whenever we want to depend on a natural resource, we need to understand how the natural resource has come into existence, how they are all renewable. The many processes, natural processes are cyclic, which will regenerate and be there for the entire life system. But unfortunately, though man is dependent on the sources available, that's how this civilization grew on the in the developed on the banks of the river. Like that, we are always associated with the sources of water. But how changes occurred, though man is the latest life came into existence in the evolution, the very short time in the geological clock, in a very short time, we have been able to distort that natural management which existed and getting ourselves into the problems. So my thinking is whether it is a spring or a groundwater or the surface water body, we have to have a overall observation and connection and understand with the background of the geology and geomorphology, because the entire water resource system came into existence because of the founding geology, what type of rocks they are and how they got weathered and how it made the water to run through And the natural stream network is like a nervous system in the entire river basin, which carries the water right from springs to the ocean. So the journey is also, it is not only rock and water, but the natural vegetation, the soil layers which created, they're all interconnected. So now the time has come to rejuvenate everything. First, we have to understand everything. How the movement of water, what is the path of this water, and the direction of the river. It is not only towards the sea, but it has its own directions to move through in the entire basin. When we divide the whole river basins into types of watersheds, the first is the spring shed. The spring shed depends on the geological origin. It could be a folded mountain or a basaltic top, tabletop mountain, or highly eroded and dissected granitic hill. So it has its own catchment. So we divide the whole hydrological boundaries into major river basins and micro, mini to micro watersheds. And we have to understand the movement of cyclicity within the micro level and then the macro level. Then only we will be able to conserve the nature, regenerate the natural processes, and make the human beings live longer in association with the other fellow beings. So when I started the thinking of using the satellite images for natural resource management, I did an exercise of rejuvenating one stream using the remote sensing, and it was successful. But that has to be replicated. It is the work of an integrated management, and it has to happen in coordination with the different departments or sectors. Like forest department has a big role, the watershed management has a big role, groundwater department has a big role, but all these players are dissected. Urban development is a big role, because when the river, if we look at the river as a large area, we have one thing is the surface and subsurface inherited geological conditions. The other one is the climatic conditions, and that's why it is nothing but an interplay of atmosphere, hydrosphere, lithosphere, and biosphere. So when we divide the whole river basin, we find a part occupied by the urban area. So we need to divide the whole basin into different types of watersheds, depending on the land use, and plan accordingly what should be made to make this water cycle sustainable, water cycle to keep rolling, and finally to address the issue of climate change. So the springs, if we want the springs to be sustainable, we need to understand that we need to protect the environment around that. We may find some artificial recharge or to make divert some water to percolate into the weathered zones like that. But more important is to understand the whole processes that had been operating. For example, I'll just quote an example. Water is always related with the two springs are always related with the spiritual centers or temples like that. But when we visit, once it happened, I was invited to address a spring which was getting dried up in Western Ghats. There is one Sridhar Ashram in Shumaga district. People come there from different parts of the country to bathe there, take a holy bath. But it was getting dried up and people were becoming upset when they travel and there was no water. So the management, the trust, they wanted me to just examine. And when I went there, it is a part of the Western Ghats where the river Varada originates. The trust to make the people happy, to make the devotees happy, they have started developing that area for a short-term stay and all that, and they have bulldozed the lateritic cap there around the stream, and even that lot of acacia and eucalyptus are being grown there. So the very source is getting dwindled. So I told them, we can't rejuvenate unless you should not do anything. That itself will help. So that was the condition there. And this is a similar thing happening many more places. For example, the very origin of Kaveri in Talakaveri, when I visited, I saw a lot of development activities which the government is boasting of. What has happened there? Around this spring, they have cut the laterite caps and even the weathered rock and put very big granite slabs around the stream, around the spring, and a lot of temple activities. So people are going there and enjoying these to see these springs. But this kind of development to attract the tourists or to make the people around happy, if we distort the very spring itself, the very purpose of going to the spring is lost. So I would like to quote another thing. It is very rare to have the hot springs. We have springs in Dakshina Kannada, South Kannada, Mangalore district, where there is some warm water is coming out near the Badadraka stream, which is a part of Netravati. Around the stream, lot of horticultural development, areca nut, coconut, plantains are being grown, and because of this scarcity of the water, they are drilling borewells around that. So please think of the very sustenance of this spring. It is being lost. So similarly, in Kolar district, there is a group of hills called Antaragange spring is there, where there is a small catchment of 2 to 3 square kilometer on the hilltop, where that local catchment is leading for a spring near the dike. There is a dike which cuts that flow into the major giant line, and because of the exploitation, that is getting dried up. Now they have made the roads to reach that area, and people are trying to dig more wells and more wells. So that is the type of development we do, which will spoil the sustainability of the spring. Hence, it is my experience since almost 8 years we have been rejuvenating the rivers. when we think of rejuvenation of a river, it is not only the water, but the entire ecosystem we have to address. If we need to have water, we need to have the soil layer in the catchment, which is anchored well to the ground to support the natural vegetation. Then each tree will have a very good root system which absorbs the water molecules and pump it to the canopy. At the same time, it provides the water to the gravity zone, and there is at a micro level there is cyclicity of water. Hence, it is necessary to address the issues of natural vegetation. So, in our project, what we are doing is to harvest the rainwater, because now it is very difficult to bring back the original forests, original natural vegetation, because the forests are converted into agricultural lands and agricultural lands are converted into industrial area, urban area, or highly irrigated area. So, the very natural movement of water seasonally got distorted, and wherever we had very good water potential, now needing to get the mineralization of the groundwater and issues of fluoride, even the nitrate, etc. are coming. It is, even if we have water, especially in the urban areas, it is so much polluted, and we are into big problem. Hence, in our projects, we have to map the entire river basin. It is not enough if we just address a small one water body, because there are so many people, so many associations, so many departments working for water, but not in a very integrated manner and addressing the issue with a framework of river basin. So, in our projects, what we do is first we map the entire river basin for the availability of the natural streams and overlay that streams using the remote sensing and very good tool of GIS. Overlay these thematic layers one over the other and find out how the rainwater can percolate and pervade the entire basin through both the shallow and deeper aquifers, which will in turn lead to the environmental flow in the streams. These environmental flows, what engineers call as base flow, to come up, we need to work in the right from the upstream area, right from the springs to the plain, and you all know how the river is divided into the youth stage, the mature stage, in the old age, etc. Now understand that and prepare the plan of action such a way wherever it rains, the rainwater is the source, and that too in the peninsular India, all these rivers are rain fed, and make a policy to see that instead of going for very big projects, diverting and taking the water from where to somewhere, we need to address the locally to harvest the rainwater and convert that rainwater into the groundwater to fill the shallow aquifers and also the deep aquifers, because the hard rock terrain, the aquifers are fractured, have the fractured porosity and the weathered porosity. So the entire zone, if we can harvest rainwater and recharge it, it will go a long way. It is not enough one or two places if we do. we have to address it in an entire river basin so that each and every village has to be water sufficient and lead to the climate change. So presently I'm working on a spring. When Abhilash and Purandar contacted me, I was in the field working around a spring in Kolar district, Chikbalapur district, where the river Palar originates. It is a large chunk of wasteland. It is identified as wasteland in the land use map by the remote sensing application center. And this large chunk of wasteland, it is not a wasteland actually. It is a small hillock with a difference of 40 meters from the ground level, but highly undulated. Very big boulders of granites and gneisses are intermixed, and lot of fractures are there. If you just see even in the Google Earth, you can see how it is dissected in different directions and make the water flow vertically down. Whenever it rains, it can percolate in between the gaps and and to my surprise, when I was just doing the field work, there is a lot of good soil developed below these boulders, and they are very good aquifers and highly weathered lateritic soils, and the rainfall directly, it's on the nature itself will convert into the groundwater. That is how there is a spring in the downslope where there is a temple, and in spite of even the failure of rain, that spring keeps flowing very slowly. But what is happening now is people that to this they are fond of grabbing the land. Some of them, they are trying to move the boulders with heavy machines and encroach that land because there is good soil below, red soil, which is very potential. Because earlier the vegetation cover was there and organic content of the soil is so good and it is porous. It is very nice for the people to go for agriculture. So this thing, if it continues, the entire the hillock or that spring shed, it is the spring shed which gets distorted. So now, with the help of Rotary, we have launched a project called Eco Restoration in the Upper Palar Basin to protect the origin of the Palar River. So the Palar River flows start from a place called Guttahalli in Chintamani Taluk, and it continues in the major part of the Kolar district and continues in the Andhra and Tamil Nadu. So our plan is to plan for the map the entire Palar River basin, and it is and the about 15% is in Karnataka, 27% in Andhra, and the rest in the Tamil Nadu. So we have plans to cover the entire basin for managed aquifer recharge and simultaneously address these wastelands. So even the governments are supporting. Karnataka and Tamil Nadu government both are supporting. We are yet to enter the Andhra in between. So when we address this entire basin, we can find so many springs in the starting point of the streams. The springs are the starting point of the stream. For example, in that Guttahalli, whatever the spring is there, that is the first order stream which starts, and this stream network continues till the sea. So the journey of the spring water should be connected to the entire geohydrological scenario. That is our objective. So there are many, there is a highly undulated terrain where many hillocks are there, where the springs originate. So the river rejuvenation program will start with the addressing the wasteland where the springs are there, and when we started working around that spring, it was a surprise for us when we used the geophysical equipment, 2D earth resistivity tomography, we could find large dimensions of aquifers which are connected. So whatever the heavy rains it occurs in a it could be very rare also, but it can contain such a large amount of rainwater and keep percolating and distributing it not only at the shallow level, even at the deeper level, because you could see the major lineaments cutting across even the basins. So the journey of water can be on the land, will be spread over in a large area, and it will support the groundwater regime and also make the river flow when it gets elevated or the water table rises. It is a very difficult task. It is a big dream, of course. So what we are doing, one side, in the near that spring, we have set of villages, 7 villages, which happens to be a part of one panchayat. So in this panchayat, we have 700 farmers who are using the groundwater for their support of their grow vegetable fruits and also their food crops they are growing. This entire area, 700 farmers are having some 500 borewells, of which 100 borewells have failed. When we conducted the geophysical survey, we got a hope that if we continuously harvest the rainwater in this hillock, the spring shed, it will support the supply of groundwater to these failed borewells also. But one is the supply side, another is demand side. So we are encouraging the farmers to go for what is called as agro-horticulture, agro-forest, so that the consumption of the groundwater become less and there will be scope for water table to rise. So the entire thing we have been able to survey and enumerate the crops growth and what is the potential. We are conducting the aquifer test, pumping test, slug test, and coming out with a scenario of how in a point of origin of a river, how the water gets distributed and how it is being utilized. And also that we have with a set of expert foresters and botanists, we studied the area to find out what was the original species which was there and which got distorted, and to regenerate that kind of hydrological scenario, we are planting such trees on the hillock in between the gaps of the rock outcrops, and see that the water cycle there itself will become very active and proceed further. So it's also our plan to map the entire basin and find out how many such springs are there where the aquifers start working for the groundwater and make this entire basin waterage. Along the streams, we have been able to harvest rainwater by way of making the water flow slow. Instead of check dams, we are going for what are called as boulder checks, which heavy boulders are put in juxtaposition and pegged so that it will not stop the running water, but it makes it slow and increase the soil moisture. Then next to that, we are going for a 20 feet well which penetrates and make the water connected to the shallow aquifers, where our farmers were depending on open wells. When I started in 1970 in that area only, we had water to a depth of 1.5 or 2 meters. Now there are no open wells at all. They have closed it. So when we do this kind of recharge wells all along the stream very frequently, because the whatever was happening through the natural vegetation is not happening, but more siltation is occurring, and we have a number of lakes in that area, tanks, which are silted up. They were like bowls, but now they have become, instead of storage place, they have become evaporation pans. So these streams, when generate the groundwater at the base flow, the tanks will receive the water even after the rains stop. So we have to desilt the lakes, but for the time being, what we are doing is we are creating a storage place or a kalyani or the step well within the tank so that it is supported by the groundwater, because where the stream enters the water body, where the geomorphologically very congenial condition is there, we go for what are called as water pools with a dimension of 100 by 100 feet and 15 to 20 feet depth. So we have been seeing such water pools wherever we have created. We will have the water throughout the year, and the cattle are going and drinking water, and around the water pools we are creating the tree park. The native species of plants are grown there to create a eco-restoration cell. These tree parks are attracting the bees and birds, and there will be water and shade. Such every tank, we are creating such water pools and parks so that it will start conserving the water in that area and change at a very, very micro level. Climate conditions are changed. So next is we are also interested in desilting the tanks and strengthening the bunds. So the journey from right from spring to the water body, it has to be safe and sustained. So the agroforestry, managed aquifer recharge, and the wasteland development, not development, wasteland to convert into eco-restoration areas are the attempts we are making for our river rejuvenation program. So this is being done. This is whatever the methodology that we have evolved in the Kumudvati River Basin and Palar Basin is very replicable, and in Naganadi, a tributary to Palar in Tamil Nadu, has been very successful because the hardworking women folk, 2,000 people, they worked in that area, and we could see even the open wells getting water, and the sustained flow in the river is noticed, and even the Prime Minister recognized it and talked in the Man Ki Baat, and the Tamil Nadu government has taken it as an example, and it has been very popularly known in the entire country, the Naganadi case, and we are working in different river basins of Tamil Nadu also. So this is very good for the hard rock terrain. But in the case of basalts, I visited the Nasik area where there is one Gavanda village. HAL wanted to support us for a project there. I could see there also the deforestation along the slopes of the basaltic hill area. So it is getting degraded. But very good jointing, pentagonal joints are there where the water can percolate. And we have the vesicular basalts in between. That is very well explained by the speaker spoke in our before. And if we can create some, because we can't create the forest in a short term, if we can create some funnels on the flat-topped hills along the stream network, it would easily percolate that water and connects the horizontal layers of aquifers below, which will seep the water to the water bodies. So this kind of connectivity and overall movement of water with the vegetation will definitely make the area water sufficient and climate resilient. So these are a few of my experiences I could quote, but there is a lot of things to happen. Even these methodologies will differ from different geographies and geological horizons. We need to work together. And I'm happy this Institute of IA, Institute of Hydrology is coming forward, NIH is coming forward to associate with us also. And we have been working with the professors of the environment from the IISc, and we have very good understanding with the ISRO. So we use all the available technology and science and come out with a plan. And above all, there is community participation is very important. So we need to educate. Now that in the spring around which we are working for the 7 villages, we are creating the water professionals by training the farmers, young farmers, to educate them how to monitor the water availability. That is what being foreseen through the Atal Bhujal Yojana. Water budgeting has to be made, and they have to prepare their own water security plans. So if this can happen in all the villages, each micro watershed, simultaneously, definitely there will be a big change in the climate, and there will be a rich natural resources, and make the human life also sustainable along with the nature. Thank you very much for patient hearing. Any questions are there, you can ask.
Hello.
Hello.
Thank you very much, sir. Thank you. And I request the participants now. Any questions? He shared a very large experience which he had. If any participants have any questions, please kindly interact with Dr. Lingaraj sir.
Hello, sir. Hello.
Yes, please.
Hello. Good afternoon, Dr. Lingaraju, Purandara, and Sudhir Kumar, sir.
Thank you. You are welcome, sir.
I'm Dr. Nandish, professor in SAT College of Engineering, Tumkur. Really, it is a very good experience talk by Dr. Lingaraju. Without using any materials, he has explained more than 45 minutes. Regarding my question directly one to Mr. Lingaraju. Since I am involved in the research study of groundwater, surface water, and geoinformatics, roughly 3.5 decades, I would like to ask one question about a small water resource structures called a Talpargis in Tumkur district, especially in Madhugiri and Koratagere taluks. We have this type of structures. We can get lot of water during summer season. Can you add a few tips or a suggestion to enhance or develop these small structures called Talpargis? Because you have worked as a director in the groundwater state groundwater board and Karnataka State Remote Sensing Center as a director, WRDO, and your rich experience. And you had explained about Antargange of Kolar and so many things. I know about these structures also. If you give some suggestions, I am going to work further about these small structures. They are called Talpargis. Can you, sir, please?
Yes, thank you, Dr. Nandish. It's a nice question you asked me. Right now, we are working just 2 days before we were in Koratagere Taluk to identify some tanks for rejuvenation. And I know this Talparges were thing of past now. Actually, the Devara in Durga is a big hill range which is highly jointed and the boundary terrain is there. Whatever the rainwater occurs directly percolates vertically down and reappear in the stream network. That will, and fortunately that area, the Pavagada and Madhugiri and even parts of Gauribidnur, we had a lot of Talparges. These Talparges are nothing but in a sandy zone. If you scoop the sand, you will find the water. They used to pierce the bamboos, big bamboos, and put the footwall of the pump and they, at a very shallow level, and they were pumping and irrigating lots of even the sugar cane was grown those days. That is earlier to 1970. It is in the 60s. So those Talparges now are not there because one is the removal of the sand. The other one is the over exploitation of the groundwater in the upstream area, right from the hill slopes of Devara and Durga. We have the Jayamangali River and also the Suvarnamukhi River, which joins the North Pennar near Gauribidno. The entire stretch is a plain ground there with a lot of sandy soils, and we had that kind of geological scenario earlier. But unfortunately, because of the sand mining and the over exploitation of the groundwater, these Talparges are disappearing, unfortunately. Maybe one or two we could see some, but it was a thing of past where even some geologist earlier to us had estimated how much of water was available in those Talparges. Now it is not appearing. So right from the hilltop, wherever the springs are there, you have to conserve water and take the entire riverine ecosystem has to be addressed. Maybe now with the understanding with the government of Karnataka, we have a program called Antarjala Chetana, where we are going for this managed aquifer recharge, and many NGOs, even the many corporates are helping us to take up this eco restoration in different areas and desilting of tanks. So, to make the water sustainably available, we have to address the entire ecosystem, which will definitely give some good results. Thank you, Dr. Nandesh. Maybe you can even join us in your efforts and you can use your students to bring more awareness along with us. You are most welcome, Dr. Nandesh. Thank you for having asked this question.
Okay, thank you, sir. Thank you. One more small question to Purandar is a request. Sir Purandar, if possible, can you add at least a brief talk about application of environmental isotopes in this workshop series? If possible, 10 to 15, because Sudhir Kumar also involved as a coordinator. Can you, yesterday you have suggested an application of environmental isotopes. Since I am working on that, if possible, you can add 10 to 15 minutes about that. Thank you, sir. Thank you.
Yes, sir. Actually, Dr. Sudhir Kumar is not available today.
Yeah.
Yeah, he's out of station.
Okay.
So I am also not prepared because this one.
Yeah.
Otherwise, I would have given you the idea what we are doing. We have done extensively for Maharashtra actually
Okay,
during our first hydrology project to estimate the groundwater recharge, etc., by using carbon tritium tagging technique, etc. Okay, so I think I will share you the literature also, what we have done and the literature what we have. That I think. Thank you, sir. Thank you very much. So, any more questions, please? Sound ready?
Sir, myself. Hello, Lingavaju sir,
Yeah, I can hear.
Listen me? Sir, myself, Dr. Vijay from GSDA Pune, sir. Sir, your topic was on regeneration of river basin.
Yeah.
But in your talk, you have very elaborately talked about many things. Means importance of morphological feature, then geophysical technique, and need of conservation of spring sheds like that. So, sir, is there any designated methodology you have prepared for this whole thing?
Yeah, we have been, since 8 years we have been working, and wherever the success stories are there, they are replicable. Now that whatever we started in Kumudvati was applied in Vedavati, Palar, even in Tamil Nadu, Naganadi, etc. So there, it needs some modification depending on the terrain specific changes in the lithology or the geomorphology. If it is, if we go to the coastal area, it will be a little different. If it is a more sandy area, we have to need to go for this what are called as subsurface dikes. In Orissa, we visited where the large river streams are full of sand, and there will be very good rain during the rainy season, and summer there is no water. So we are just addressing those issues. We are also thinking of having a sort of a team of experts like you working in different areas, where we can come out with the different methodologies, maybe 10 or 12 typical geological scenarios may be there in the country. So we need to work out the methodologies, and by doing some applying it for pilots, we can establish and make everybody to practice such methods in their respective terrain.
Thank you, sir. Thank you.
Anybody else? Anyone? Please. Okay, if there is no more questions, I would like to thank Dr. Lingaraj sir. Actually, I am also seeing him after a long time. I took his guidance during my early part of my career when he was in Belgaum as well as in Bangalore. So when I just telephoned to him, he just kindly agreed to deliver a lecture, and a very interesting topic you delivered, sir, where everybody is stressing on the river rejuvenation, which is very essential, and you have practically witnessed it. So on behalf of National Institute of Hydrology and on my personal behalf, I thank you. Thank you very much for your kind cooperation and support which you rendered during my webinar, this organization. Thank you, sir. Thank you very much.
Thank you very much.
So now I would like to go for the third lecture. That is the third and the last lecture by relatively a very younger person, Dr. Professor Girish Gopinath, who will be talking about the springs distribution, etc. from Kerala. So just a brief introduction I will give about Professor Girish. He has done his master's in geology from Mahatma Gandhi University, Kottayam. Later on, he did his MTech in remote sensing from Bharatidasan University. And of course, he was my junior in Cochin as a PhD. I left long back before he joined for PhD in Cochin University of Science and Technology. And later, he has lot many things to his credit. He has been a consultant, or he worked with the various organizations in Dubai, and I think in various Middle East countries. As a senior geologist, he worked right from 2005 to I think 2007 or 8. If there is a mistake, kindly forgive me. And later on, he joined as a scientist in CWRDM, Center for Water Resources Development and Management Organization in Kerala, which is doing an excellent job on hydrological studies. Especially in Kerala, all those problems are solved by our CWRDM, and they are doing much better than in many other parts of the country. Also, they have taken up some project, and one of the most enthusiastic fellow, Dr. Girish, and later, of course, he got citations as well as he got lot of awards for his best publications and also for outstanding contributions in the review and various journals. And really, I am very happy to introduce him. And Dr. Girish, I welcome you and to share your experience in this webinar, which will be very fruitful for the participants. Hello.
Thank you, sir. Hello.
Yes, please go ahead. Say.
Yes, sir. Okay. Sorry, is it visible? Hello, sir.
Yeah, it is. It is visible. It is visible. Yeah.
Okay. Okay, sir. Thank you for nice words by Dr. Purendra, sir. So my talk will be the drought mitigation and development for spring in the regions of Western Ghats for the community water supply scheme. So the background of study is actually what we are talking Kerala. We are getting a rainfall of 3,500 millimeter, the annual rainfall. Even though we are facing the drought years, even 2007, 2010 like that. That is why we have taken up the study with the help of government of Kerala as well as the government of India. So actually what happened Kerala, we having it is classified into three. We having a highland, midland and lowland. The high altitude region with a hard rock overlain by thin layers of soil. Water development through this construction of well is very difficult. So what happened? So this steeply sloping topography along with the frequently changing the land use also play an important role in the water scarcity. And also the wastage water from the undeveloped spring even during the summer. The absence of structures are very important in the country as well as in Kerala. So we have taken up the study how we will mitigate the drought using our natural springs. So this is the situation in Kerala. So we are experienced a monsoon. We are having a 2 monsoon. We are getting a lot of rainfall. But even though we are facing the crucial drought, even April, May, March, April, May, and the rainfall concentration is also it's significantly decreasing trend. Actually, in the southeast monsoon is showing a significant downward trend as a meteorological data analysis is there. This is one of the project we carried with the Ministry of Water Resource, INCO project, to study the drought pattern of Kerala. First, we studied drought, then we see how mitigate our drought. So first, we have done a survey with the drought with using satellite data, using lot of indices. I am showing some one indices only. And this is one of the drought anomalies in 2007. The red region, you can see all this drought pattern. Based on the background only, we gone for our traditional water resource. Basically, we having a lot of traditional water resource in Kerala. Usually we having the open well density is very high in Kerala compared to any other states in India. But the problem we are facing in the highland and midland region of Kerala. Actually, if you take a Kerala, it is classified into three, the highland, midland, and lowland. The 0 to 7 we are talking as a lowland, 7 to 70 we are talking as a midland, above 70 meters, above MSL we are talking in the highland. So highland region we are facing a lot of drought in these drought factors in the country, in the region. Thought of the spring. The spring has a good scope for developing or mitigating the drought in the especially for the highland region. But the thing is that the quality of water is good and the supply also we have to see whether it is a perennial or non-perennial. And the another easiest way is that the most of the cases spring water can be brought to the usage by simply a gravity flow. There's a no need of power like that. So the gravity will be help you to get your resource. High scope of gravity distribution of spring-based water supply scheme in the highlands of Kerala. Nowadays, most of the people are aware about Jalanidhi, one of the project of World Bank. So what they are getting the resource from this spring. Most of the Jalanidhi project, the source of the water is from the springs. And they having one storage tank, then they distribute to the midland like that, from highland to midland, or they will distribute with the highland itself. The initial cost is required to utilize the spring comparatively low, and the maintenance cost is also minimum. The feasibility study of spring resource is essential to investigate the quality and quantity. So I will give a overall idea about Kerala. Then I will concentrate in one state with a more research oriented one. The first some slides, it is a basically deals with the Kerala, how many springs are there, what is the classification of spring like that. Then we have taken one district from Kerala. Then we'll explain more research wise like that oriented. When we talk about the springs of Kerala, we basically there's a lot of classification. I will not go for the classification of spring like that. Mostly what we are seeing in Kerala, it is a gravity springs. Whether we can say it is a wet weather spring or a perennial spring. The perennial springs are not going to, maybe a lot of people have covered these things, so I will not go to details all the things. You will get a lot of information from if you go to www.keralaenvis.nic.in. You will get a lot of information on the what are the potential to be developed, a good source of drinking water supply, and also for limited small scale irrigation purpose also. So it's a background study, but is the open wells are not common in the highland. Already I mentioned one of the state having a high density of open wells, but in the if you take as a highland region, open wells are not common. So people are usually depending on borewell. Again, there is an issue with the borewell in the April, May. There is a scarcity of water or drying up of borewells like that. And there is a severe drought phase. Now people are talking about the climate change. Then we are also facing that thing. There is a change in the decreased trend towards the southwest monsoon. As a lot of drought years are coming. That even though we are getting a high rainfall of 3,500 average or 3,200, but we have steep slope. If you compare to the our slope is also very steep. So whatever the rainfall we are getting, it will reach the Arabian Sea very fast. So based on that only, we have carried out this research. And if you go to springs of Kerala, we having a 236 perennial springs having 181 perennial springs are located in highland. Many of them are a significant discharge for the domestic water supply scheme. That's the importance of the springs, especially in Kerala. I will discuss later about what are the problems we are facing to development of spring actually. Then there is a natural spring occurring in highland region have a potential development as a good source for drinking water supply and also limited scale of irrigation. So these are the district-wise distribution of springs. We having a 230 springs. There is a lot of springs in Kannur, Wayanad, Kozhikode. It is in the northern part of the area. These are the basins. We having some 44 river basins are there. Out of three rivers are flowing to the eastern part. Another 41 is flowing to the Arabian Sea. Most of the river basin. They having a springs on the upper catchment area. So these are the distribution of springs in Kerala. It is a river basin management. It is a river basin management. It is again, it is a classification of springs based on the elevation. So you can see the most of the springs are situated between 700 to 900 meters above MSL, and some are 0 to 199 meters elevation. That means most of the springs are seen in the highlands and midland, but we having some coastal also. That is Varkale, that is in the southernmost part of Kerala. We are getting some coastal area. That's a coastal springs. Search in Google, you can get a lot of information. Now, it is geologically very important that Varkale formation. They having a lot of springs there, but usually these springs are distributed in the midland and highlands of Kerala, and this is the discharge-based distribution of springs for entire Kerala. When you take this one, you can see it is a 1 to 99 and 10 to 90 is a 200 liters per minute is more than some 150 springs are there. It is a better for the development of springs in this area. And this is an old classification, main classification. Usually we are calling as the first, second, third, fourth, fifth, like that. Some this is a classification. Still, people are following this classification to classify the spring based on the discharge. And most of the Kerala, the spring are falling in the fifth, sixth, and the seventh category, like that. It is a based on the discharge of springs. Kerala, overall, this is a distribution of springs in Kerala at a single figure. We having a more than 38,000 square kilometer, and you can see the highland is mentioned as the green color. The midland it is mentioned as a cyan, not cyan, it's a pink or something. Then your coastal area, you can see it's a yellow color, but you can see on the bottom part of the figure, bottom part, you can see the some spring that is in the Varkale formation. It is actually those who have studied geology, you will become across the Varkale formation. So you are getting some springs in that area also that you can define as a coastal spring. Also, they are having a perennial and also good discharge for the water like that. So based on this one, we having some idea from a Ministry of Water Resource. We have done some work for them and for UNDP, and also we carried some work for the spring development. So taken a project with Kerala State Science and Technology, that feasibility for development and management of spring for the domestic water needs of islands of Kerala with a special emphasis of Wayanad. The Wayanad is the one of the district. We are having 14. It is a one of the district in Kerala. It is on the northern part. When you talk about geologically, it is a plateau. It is a more than above 750 meters above MSL. If you take a Wayanad, there's a lot of reports are come in the Hindu like that. Why the district have only 70% of groundwater development. This is a report from CGWB 2012. 90% of total population, that's a 7.8 lakhs people is depending on agriculture. Among the 1.36 lakhs belong to various tribal. The one of the district having most tribal population is the Wayanad. So that's why we are stick on the project to the Wayanad, because the lot of tribal people still they are using this spring water as the source for the domestic purpose. That is why we are selected for this study for the Wayanad district. So relevance, the entire region is facing a recurring drought due to changing rainfall pattern. Because when you take a Wayanad, we studied a long-term pattern of rainfall in this area. There is a place called Lakadi. If you search in Google, you will get a Lakadi. That most of the days you are getting a rainfall is a diesel like that in some 70s and 80s. Nowadays, the scarcity of rainfall is the main problem facing by the Wayanad. So that is why there is a lot of changes in rainfall pattern, and there is a scarcity of water. The only we can mitigate this one only through the development of spring. Only we can mitigate this one. So actually, this is actually I copied from my project. I'm not, but somebody is asked about isotope. I will explain, but there is no data I am showing about isotope. to elucidate and isotopic signature of spring water. It is basically, we want to know what is the concentration of ionic concentration, basically major, but it is a prostate. When we see this one, we have collected the water from the source of spring. The water is prostate, just like it is less than 500 TS and EC. So you can drink directly. The thing is that, but you have to see whether any bacteriological contamination, because there's a, it is not on the mouth of the spring, but when you distribute, there's a chance of contamination. And also one more thing, it is that it is very highly agricultural area. It is an agrarian climate condition. The people are doing coffee, cardamom, like that. In the entire district, there is a lot of paddy cultivation like that. So there is a chance of mixing not on the upstreams. When the spring, when you come to downward parts, there's a lot of contamination from the downstream part only. But in the on the source, it is very prostate. That we have conducted, we have collected samples more than 73 locations for the isotopic and ionic signature. And isotope data is also we have collected. The Center for Water Source having an isotope national facility lab is there to be carried out O18, O16 identification of this signature of isotope. Then we have classified what is the recharge area of springs like that. Actually, I have not included anything about isotope, but if you are very interested, I can send you some literature like that about isotopic signature. There's a lot of studies conducted by NIH also from isotopic signatures of spring water. And I can add one more thing about isotope. The isotope is the best tracer. It's a stable isotope like O18 and O16. You can do a lot of wonderful work. So you can also get a lot of information where the spring is recharged from which part of Western Ghats, like that. Whether the signature of O18, O16 is changing, whether it is mixing with the groundwater. So there is an interaction of spring and groundwater. Lot of investigation you can do from an isotope signature. That is the first part of objective. The second part is to ascertain what is the present utilization of springs and recommend the ways and need and optimally use these in future. So whatever we have taken, we have all the photographs is geotag. We having all the GIS facilities are there. So whatever the samples we have collected, we have developed in a GIS platform. We are actually developed a information system for the springs of Vaina. Whatever the information we have collected, we have put in a GIS platform, and the photographs also geotag. You will get all the photographs, this one in our local website, not in the public domain, is actually in the our intranet like that. So this is a questionnaire we are given. So you can also develop your own questionnaire. It's actually prepared by our teams. So we will ask which is the river basin, which is the nearest town, what is the approximate elevation, land use around spring. The main problem what we are facing this one, when we study the land use pattern using a satellite data, there's a lot of changes in the land use pattern. Even though the Wayanad is a plateau, there is a lot of restriction by the government for the building. Even though there is a lot of land use are fastly changing because of the tourism or the purpose. When we compare some decadal changes of land use, there's a lot of changes in the land use in this one. The ownership is the main issue. The thing you have to keep it always in mind, ownership. We have 1,000 or 500 springs are there. Maybe out of 50 will fall under the private property. It is not a public. So you cannot do any development activities. That you have to keep it in mind. Whatever we had visited in Wayanad, all the springs are under the tourism or a resort. All the springs are situated in the tourist area or within the resort. You cannot do any development activity even for the tribal area. That government should ask for a you cannot do any. That's the ownership is the one problem I want to stress. Even the government also have to take some action. this spring for the public, not for the private people, because all the private people encroach the spring. They make very good ambience in their hotel like that. Ownership is one of the issue. Then the perenniality. Because when you go for the development, we'll go for the perennial, this one. Then discharge is the main issue. The discharge you have to see. If there is a no discharge, there is a no need of going for the this one. What is the current summer, monsoon, like that. We have done all this analysis. Then we have done water quality. I already explained the water quality is a pristine. Well, some people are used for the irrigation, agriculture purpose. So all the things we have noticed, we are observed, and the storage structure is any is there. That also we had mentioned. The future development possibility, whether this spring can be used for the future development. And if you are a geologist or if you are from this background, you can write what is a type of rock. Usually when you go to the Wayanad, it is a granite and some charnakites are there. Then the springs are seepage, fractured, joint or others like that. So there is socio-economic benefits. Also, that is also what are the number of beneficiaries, whether that is used for tourism. I already explained. Most of the springs are under the resort people, but we cannot do any development activities like that. So distribution of springs in Wayanad. When you see this one, this is a Wayanad northern part. Wayanad is in the northern part of Kerala. You can see there are a lot of springs are there. More than 70 springs we are identified in the different part of Wayanad. From this one, and also a lot of streams also identified. Of spring with respect to geomorphology of Wayanad. When you take a geomorphology of Wayanad, there's a when you start with the denudation hills on the southern part, and there is a dissected middle plateau. Then the outer fringe middle plateau, I already explained, it is a plateau. It is having a more than 700 meters above MSL. That is a classification of springs based on the geomorphology. So I will explain later how the geomorphology affect the springs like that. So this is a classification of springs. So methodology what we had adopted is a GPS and Google Maps are used for locating site within the administrative boundary, mixing with your topo sheet or something. You having a 1:25,000. Then we are gone for the inventory of springs carried out based on you can do your own inventory, and lot of inventory is available with the GIS or GSI also. Local knowledge and field survey. It is a very important things for any type of survey and integrated with the remote sensing and GIS techniques for land use changes like that. And the discharge of spring have been carried out seasonally. So that is very important when you want to study whether it is a perennial or non-perennial. You have to study a seasonal analysis. So 73 springs are being classified in 91 Keni. That I will explain later what are Kenis like that. Then we are done isotopic composition of spring water is also carried out for the entire 73 samples. And when you go to this springs of Wayanad, you can see it is basically the pie diagram is classified. One is a perennial and non-perennial. When you see the perennial, you having a 52 perennial springs are there. The 33 are non-perennial springs. Again, 52 is again classified. Is having an owned by tribals. It is toll numbers used by tribals by or forest, then public, then private, and the forest. You have to see the 6 numbers of perennial springs are falling under the this private property that you cannot do any development because it is actually it is under the hotels or like a private. That's the main thing. If you go for the development of springs, you have to the ownership is very important. Unless government have to declare the springs are the property of a citizen, then you can do a lot of development activities. Unless you cannot do any activities, that people is also very not able to reveal anything about the spring like that. We'll ask whether the water is there. Then they have some fear that the gunmen will take over the spring like that. So the inventory also we will feel a lot of issues in between like that. So overall classification of springs in Wayanad based on the perenniality, classified perennial and non-perennial. Within the perennial, we are classified by how many tribals are used by tribals, that is in the forest. There is a Wayanad, there is a lot of forest area is there. Then we are going with the public, then private and the forest like that. When we go for the chemistry of this one, once you know the chemistry and quantity and quality, then only you can go for the development. We can give the government which are the spring, you can go for the development. So we have carried out both the pre-monsoon, post-monsoon and monsoon on. We have seen, when you see this graph, the concentration is very less for pH, alkalinity, total hardness and major cations and anions. It is expressed in milligram per liter. And this going to explain, most of the people are familiar with this type of diagrams because this actually we prepared for our presentation for the final presentation of this project. And what we have seen in the Wayanad, the most of the springs are fall under the category of 6 and the 7. The miss is this one. So the 6 we can use for a future for a better for this one. And these are the some comparison of your parameters with the springs of Kerala. There is a lot of study carried by a lot of people. It is in the Wayanad, the another two in the southern part. So to compare what is the difference between pH, EC. When you see this data, the water is very pristine because all, if you see the EC, it is a maximum 114. That means it is a very pristine water to drink. But the thing is that you have to collect the water from the source of the spring for the development. So observation what we are seeing, I am not saying a conclusion this one. The average pH of perennial of Wayanad is 6 to 9. This one 9 maybe because of it is a lateritic soil. The 6 is acidic like that. An average of EC is a 115 microsiemens per centimeter. And the geomorphological control over the distribution of spring in Wayanad. That is also we have noticed. The spring are aligned in a separate fashion. That is why we have done further analysis how there is a control on lineaments or some other factors on geomorphology on this one. So general alignment of these spring are west northwest to north northwest direction with the emphasizing the major lineaments of region. So when you go for any type of research activities, not for type of investigation, this type of things you have to be very careful. What type of geomorphology the spring is falling, and whether the spring are falling in some linear fashion, some control is there. So we have done all the type of investigation using satellite data. We have derived geomorphology. So the most of the springs are aligned in the north northwest and north northwest direction. The springs are identified as situating in dissected middle plateaus. That is also another observation, and the higher elevation than the valley and valley fills. There is a lot of valley and valley fills, and these are the observed in the middle plateau like that. Springs are rare in dissected middle plateau region, residual hills and out of ring middle plateau. These are the some observation we had seen from this that Wayanad area, that particular area. So when we have done a simple schematic representation, because we had seen if you are collecting a water from the mouth, you want a small storage. From storage, you can, from gravity, you can convert to a collection unit and filter that with a sedimentation distribution like that. You can keep the water for some time. If it is a turbid, usually in monsoon season it is turbid, it will settle. Then it will overflow to the public utility taps. Like that. This is a simple mechanism following by the government of Kerala. There's a lot of government has suggested and completed by even NABARD also have been in Wayanad. They is working for a development of springs, and NABARD having a lot of projects. This one. So given the recommendation for a simple recommendation. And these are some springs in the Wayanad state. some small discharge. I am not having a good photographs. Actually, this work I had done some 4 years back. And these are the Keni. I already mentioned the Keni is the one of the water obstruction structure. You can see only in Wayanad. No other area in Kerala, you will not get a Keni. Keni is the one of the obstruction structure. The Kerala is the one of the peculiar area. Other than springs, we having a water obstruction structure, horizontal wells that we are calling as a Suriname. It is actually in northern part. The another one is called Keni, and in between one, our project was concentrated on spring one. Also, we had done some study on the Keni also. So these are the type of Keni. It is in the ICR Agriculture University, and this is another Keni. It is in the Pakam. It is in the Wayanad area, and you can see the ring is made up of palm tree, and also sometimes it is a jackfruit like that. So it is also very pristine water. So we are a very detailed survey on this one, why your Kenis look like that. So we had seen lot of Kenis, but people are slowly shifting and changing the palm to a concrete one, because their kids are falling on this one. So they are changing the Keni. So again, we are doing some, we are not published that isotopic data. We are done both isotope as well as this one. So my conclusion is that there is a good scope of gravity distribution of spring-based water supply scheme, conservation of overnight wastage of water from undeveloped spring. Spring-based community water supply scheme in the highlands of Kerala is highly beneficial for the people in remote rural areas and tribal settlement, which enable, and this will improve the socio-economic and health condition of people, especially women and children. So actually, we have given the recommendation to the government of Kerala. We have pinpointed what are the springs government can be, what are the discharge, what are the different springs with a latitude and longitude. We have submitted the of government of Kerala. So government will give to the panchayat. The panchayat will do the development activities. And thank you for your patient hearing. If can any.
Thank you, Professor. Thank you very much. I can allow for some questions if anybody wants to ask. Hello, participants can ask.
Hello.
Hello.
Yeah.
Hello. Good afternoon, Dr. Gopinath.
Yeah.
Very nice presentation. I want to know, is there any facility to get analysis of O18, already you said, and deuterium and tritium in your center for a paying basis?
Yeah, in our center, can do O16 and O18 analysis. They are charged.
Is there any facility?
Somebody is using mic. Can you switch off other mics?
Is there any facility for a tritium, sir? Tritium analysis?
Tritium, actually, it is not, nobody is using nowadays tritium. Actually, the activity is gone down like that, but nobody is, even I think NIH is also not doing tritium. I think so. If my knowledge is correct, you can discuss with the professor.
Bark and NIH
is doing, but Ceridium is not doing now. We doing carbon 14, O18, O60. We are doing.
Any rough idea for a carbon analysis, 14 sample analysis?
That's 2,500, I think.
Okay, sir.
But sample, if you have samples, the price will be reduced. I think so.
Okay, sir. I will contact you later regarding this.
Because I am not in the charge of that one. You can, but I will give you her number like that. I am not nowadays in CWRDM.
Okay.
You can note my mail ID tgcwrdm@gmail.com. You can send me a mail. I will help you.
Okay, sir. Thank you very much. Thank you, Girish. Thank you.
Okay.
Hello. Anybody else? Anybody else want to interact with Dr. Girish? Okay then. shall we end with the out of thanks? I think everybody is hurrying up for the lunch, so there is no more questions.
Yeah, good
So,
afternoon, sir.
yeah.
Girdhar Garu, good afternoon, sir.
Yes, please. Go ahead, sir.
I am from Telangana state. And may I know the well density? Sir, may I know that well density, either dug wells or and depth range, the yields of the wells, which is more cause for this depletion of water levels in the area, in the region?
So, question for.
Yeah. Girdhar sir.
Okay, question for me, right?
May I know that the depth range of the dug wells or bore wells and the yield?
It's some area it will come around 70 meters.
Professor Girish, yeah.
Yes, some it will come at 70 meters below ground level. Some area it is only 5 meters below ground level. Range from 17 to 5.
5 to 17 meters.
Yeah, 70.
What about the bore wells?
Bore wells, it is very deep. It will come around 150 feet to 200 feet.
Okay, shallow aquifers it will. Yeah, okay. The yields bore wells.
That I am not sure, sir. That I am not sure.
Since the yields, the draft is more, the area will be prone to be a drought in a large duration. No? So that kind of aspects also have to be considered. What I am thinking.
Actually, you are right, because it is actually the Wayanad is entirely depending upon the agriculture. They are having a cardamom, all the spices, what entire spices for the country that is provided by Wayanad. They are having a cardamom, then coffee plantation, tea, lot of things are there. They are using water for agriculture for entire district for Wayanad compared to other districts of Kerala.
Okay, sure, certainly. The thing is, the shallow aquifers will short span of time it will dried up, and again it will be recharged during the monsoon period. Since the rainfall is 3,200 mm to 3,500 mm, so that the shallow aquifers were drying up in a short span of time, and the well density also has to be considered. We have to make the distance between well to well so that it will sustain the wells and the aquifer will not be affected. It will sustain in a longer period. What I am thinking.
And Wayanad, it is the rainfall is a little more than 4,500 to 5,000. It is actually when it's the average of Kerala, but it is a 3,200. When you take the Wayanad, the rainfall is little bit high.
Okay. Thank you.
Okay.
Thank you.
Okay. Any more questions, please? So ultimately, if there is no at the outset, I would like who have given very excellent talks with their own experience and the work. It is not just a collection of PPTs and provided a lecture. All the three have vast experience working in the area, especially in inventorying spring discharge, monitoring spring discharges. So I think we are fortunate to have all the three together today for our webinar, and I thank Dr. Pradeep Kumar Naik, Regional Director, Rajiv Gandhi Groundwater Research Institute Training and Research Institute, on behalf of NIH as well as on my personal behalf to you. Similarly, to our Dr. Lingaraj sir, who has been working for the last 50 years, more than 50 years in the field, and his vast experiences with a short time he is shared with us, and I am fully by my sincere thanks to you, sir, for giving such a wonderful information to our participants. I thank you on behalf of NIH as well as on my personal behalf to you. And finally to Dr. Girish Gopinath, who is an excellent researcher right from his college days and who has been carrying out very excellent works in parts of Kerala and maybe associated with various projects and given an excellent focused lecture on springs of Kerala. Thank you, Dr. Girish. Thank you for on behalf of NIH to you for obeying me for a short notice. Thank you, Girish. So finally, I thank Director NIH, who has been the key man behind our organizing this workshop. I thank NIH Director for giving such for enabling me to organize this workshop. Thank you, sir. Similarly, Director GSDA, who was also a man who was fully supportive to us, encouraged us to take up, and I seen him. He was listening to us all the both days to all the deliberations. Sir, I am highly thankful to you. I think there is no words to express my sincere gratitude to you. Thank you very much, sir. Further, our coordinator, Dr. Sudhir Kumar, today he has been on tour, so he could not attend. So I thank him, who was the man who is coordinating our center as well as all our technical activities. Thank you, sir, for your encouragement. Similarly, Dr. Venkatesh, who is the head of this regional center, who has been standing with us for all activities. So I thank Dr. Venkatesh for enabling me to hold this webinar. Further, Joint Director of GSDA, Deshpande sir and Vijay Pakode sir, who has been closely associated with me, and they were giving an energy to organize this program. Thank you, and all the members of GSDA who has cooperated in carrying out investigations. Various people like I think Gadkari sir and senior geologist of Satara and Mr. I think Rohan Pawar, and all those who have worked with us during the investigation period. I thank all of them for such a wonderful opportunity. And finally, not at the least, all the participants and the departments who sponsored them or who nominated them. So all the departments under NHP as well as under the different organizations, academic organizations, etc. I thank them, all departments as well as all participants, for their continuous encouraging words and feedbacks. At the least, N. Vardarajan and my much more than the Madlatti and Ravi. Other than that, my project Ujjwal, Sumit and Rohit, who have been working with me throughout the last 1 week preparations of the work as well as for organizing this. And I thank all of them for their kind support and queries or assistance is required in this regard. You are free to contact me or my staff here, and will be available to you, and all the queries will try to give you the reply for that. Thank you all, and the certificates for the participants who fully attended the program will be sent to you very shortly. Thank you all. Thank you once again. Thank you, sir.
I think it's taking photos.
Okay. I think one photograph they are planning to take with. So one thing I missed, some of my friends from abroad, I think Mr. Bharat and my friends from other countries who have participated, we were very happy to see them over the web, and I am thankful to them. I missed to quote them. So we are highly thankful to you, sir, for one of the person has put up the question also. Nice, Bharat. How are you?
Thank you, sir.
Fine.
Fine, sir. Thank you.
Fine.
How are you, sir?
Okay. So, fine, Bharat. Fine. Yeah? So they all attended this program, and thank you, all of them. So I would like, is it? With this, I would like to, I think the thank you all. Thank you. Hope to meet you, all of you, whenever I get an opportunity. Thank you all. With this, I conclude the.
Thank you, sir.